Hi everybody, this video is to introduce a number of tapes that you may find relevant in engineering from a mechanical engineering standpoint and mechatronics or multidisciplinary engineering. And I want to just basically cover each one, show a little close-up, touch, feel, and applications. You might learn something neat. I don't expect people to watch this video all the way through because it's long, but it'll sit as a reference. I'll try to make sections in the video so that you can jump in later. You want to explore something before you buy it. And I hope this is a helpful video for a lot of people. I'm sure there will be errors, imperfections, so I would love to hear in your comments what I missed, what maybe needs to be corrected, and other bits of information that feel fundamental for bonding things together with tape. This is tape for automotive wire harnesses, and it's kind of like the medical tape. It has some amount of flex to it, and it's good for working in higher temperatures, like that of temperature under the hood of your car. So this is commonly used for bundling wires together. And you can see that we're getting some amount of flex in it when we try to wrap something around. So it stretches a little bit. It has strength against abrasion. So this type of tape is used with fiber on the exterior as opposed to electrical tape for applications where you're going to have some vibrating and you want to resist degradation that comes from the rubbing. It can happen when items are vibrating against one another for a long period of time. For most electrical tapes, if you find it in a high temperature and it's been wrapped over itself, you'll see that it has slid. You'll notice a gap like this and usually some sticky residue here, and so that's one of the advantages of the automotive tape. It's that the adhesive itself is ready to uphold against a little bit higher temperatures. You can compare it here with the conforming characteristic of electrical tape, where if I wanted to get this quarter wrapped in one wrap, I can. If I work at it, I can get that to expand and grab the entire radius of the quarter without extras. So that should give you a sense of the flexibility. Also, tearing by hand, yes, it's possible to tear it by hand. You just have to grab at it, and it's similar in strength to the white medical tape. These guys are medical tapes, and you'll find them in first aid kits for emergency strapping down gauze to people's skin, and it's very tacky, a little bit more than your average, and it has these serrated edges to help you grip it and tear. But usually it's going to deform just in the work of you tearing it apart. I still recommend using scissors for precision. But quality versus cost, this is probably the highest value of any of the tapes that you can get, considering the strength of it, considering how long it will last, and if there's an application where I wanted to have something with a toughness against abrasion, like this medical tape, like the automotive tape, but I need to put a label down on it, then this is a time where I would use the white medical tape. However, anything that has fibers, that has a cloth backing, this is made of cotton. This one I think is a synthetic fabric, but when you start writing on it, you're going to get a bleed, and that will actually continue to bleed, especially if you get it moist. So this is nice because it's dry already, but it's still going to bleed across, and if you're intending to label something, then plan to use a finer Sharpie. Now you're looking at a specialized tape. This is called Kapton Tape, And this is a polymer that was developed by the space industry, perhaps by NASA, and it is very tolerant of high temperatures. We're talking even the temperatures used for soldering, so probably 200 degrees Celsius for short periods. This can work out for you. So you'll find this, it is not easy to tear in any direction with the fingers. The deformation is not forgiving, so it doesn't deform consistently across the strip. It's definitely recommended to use scissors. And when you're laying it down, it does not have a very thick adhesive whatsoever. So you need to plan for your application that you're going to keep your fingers clean, your surfaces clean, dust free. You can see as I apply pressure, it is laying down, but you don't get too many opportunities before you've contaminated that with dirt or oil, and it is not highly sticky. It's a one-shot tape. So you'll find this commonly. Now the price has come down a great deal, even in the last 5 years. This is probably as cheap as any duct tape or electrical tape, and they commonly come in packs where you get multiple strip widths, and that's actually worth it because it's more tedious than you expect to pull a narrow strip out of this. And if you're wrapping something large, you want to have the narrow strips so that they lay over without wrinkling. Battery packs like LiPo is where you'll find these made. The Kapton Tape used in at-scale manufacturing, and so it's a permanent solution. But again, you need to plan where you're going to fold it so that you don't have loose hanging edges, etc. This is not intended to get hot across the whole board, but the circuit A, we have the polymer that is an insulator protecting from if I were to drop something on top of this circuit. And then B, maybe at some very specific nodes, locally, you get a high temperature, and instead of having a vinyl electrical tape like this one, you have a tape that you can be sure is not going to melt locally. Secondly, of course, you can see through it. It's always found in this yellow color. You would not find it in other colors. So since you can see through it, that allows for you to continue inspecting. That is, after you've put your item into service, you can check if anything has come loose. Now, since I just mentioned cost and I mentioned colors, this was an extraordinary find that I believe that they borrowed the same or very similar polymer, and you get much more adhesion. I'll come right back to this. But regarding the cost of the Kapton Tape, now this is a material that's intended to be qualified for probably clean room environments or space ready applications. And if you want to have the data sheet, you're still probably going to pay $30 per roll or something like that. Whereas if you're willing to forego the data sheet and not have a guarantee with your project, then you can find this on Amazon for just $7 or $8. Maybe it's a little higher now. So this tape I actually found at a craft store. It advertised high temperature, something like 130 Celsius, and is intended for, I believe the industry was when they're doing screen printing or iron-on fabric work. So this one has a little bit better adhesion, and the thickness is greater than the Kapton Tape. So if we take a bit of this and we fold it over itself, and then we're going to take a measurement, this gets you a little more toughness and probably more total adhesive area for your dollar. Okay, I verified, and this one is called heat transfer tape. That's the most common word for it when you're shopping. And now I've compared the thicknesses which should be controlled and consistent across all of this spool. Okay, so if you go to the paper and we zero that on the paper, if we take 2 layers of the heat transfer tape, we're getting 0.11 millimeters, and 2 layers of the Kapton tape, 0.09. So that gives us 45 and 55 micrometers. Sometime you may need to do soldering or resoldering of a board, and there's a component that doesn't want to stay put, and you have it more accessible on the bottom. So we're going to hold the parts in place using the tape, and then you can perform your soldering and it won't melt. You can solder your joints and then it won't melt the tape away as you're doing that work. Doing the quarter test with this Kapton tape, I'll try and tug it and fold it over. And you can see we're going to have a lot left over on the corners because it does not want to stretch, especially not in 2 directions at once. So this is the corners that you get. It only barely conformed to the shape of the quarter. So you're going to need to plan your assembly to have straight lines where you want to lay this down and fold it. Non-flexible tapes are the preferred choice for some applications, such as if I want to fill this hole with putty, I'm going to be able to get this laying down very flat. And if I put a glue or adhesive in here, and let's say I take, let's say I'm going to take super glue and fill that in, then most adhesives will not add any adhesion or will not melt this very robust type of plastic. In fact, any kind of glue such as silicone or urethane or all of your common types of glues are not going to have any permanent adhesion to this poly surface. This is very similar to HDPE, high density polyethylene, in that regard, or nylon, because it's tough, non-porous, and it just does not want to stick to anything molecularly. Of not sticking, this is the backing from a piece of vinyl adhesive fabric, and if you need to work out a very precise let's say shape of your tape without getting it all smudged and losing its adhesion, it's best if you lay down a piece on top of a backing like this, or you can use polyethylene plastic such as a milk jug, but the flatness is great here. And then you can cut it to size. It's really hard to measure out on this thin line, but you can draw long lines. You can find the shape that you need specifically, and then you can get that cut just how you need it. And then once you have your shape, if it needs to match some assembly, all right, now you can just peel it by bending the big piece of paper, and barely touching it, you can get that laid out onto where you need it. Now, rigidity or non-stretchable tape can be a big asset. So let's say I want to do some field work with electronics and I need to protect this from dusty, dirty environments temporarily. And I can seal that off, and by visualizing that I've pressed it down completely, I can be sure that I have an airtight seal on there. So covering something up on a flat glossy surface, if you were to use electrical tape here, the thing is, when you're unspooling this, in my experience, I have wanted to cover a flat surface and I was quite sure that I did not stretch the tape. If you stretch the tape and lay it down, then later on it will slide its way back together. And you really can't be sure that you have not stretched the tape. Just taking it off the spool will cause it to stretch some amount, and later it will come back to get you, and that is something you don't have to worry about with these rigid tapes. Another bit of magic is that you can work with this non-flexible tape in the same way as window film. That is like car tinting kits. If you read the instructions, they'll say liberally wet the surface of the glass, and then you can position it. We're going to get it positioned where we want it. Okay, say this is for marking for cutting or some other operation that you're going to do. Now we're going to get it where we want it. You can pin it down, and then you can use a credit card to push that out. And oh man, it does not take nearly as much skill as it looks like. You can see those bits of bubbles there, and only when you're ready you can push them away. The adhesive itself is waterproof, and you can push that out. So it's hard to do while I'm filming, and I would slice off this end here before doing it, but yeah, it works really nice. And then you can verify that you have not left any bubbles in there once you're ready. You push out the fluid, and then you absorb the fluid at the edge, and it's still sliding at this point. If I work at it a little bit, then I can get it pinned down permanently. Got to get that water out of there. I have a friend who owns a 3D printing business, and he would use the Kapton tape on glass beds in order to print sensitive materials. The adhesion was better directly on the Kapton tape, and it allowed him to peel this off. I think printing beds have come a long way, and there are newer materials, so you may not need to do that ever again. Rigid tapes can also be a savior when you're working with fiberglass or flexible materials and you don't want it to flex. So if I need to cut this to a certain shape, then if I measure it out, let's say I need a 10 centimeter square, and I'm going to mark this, and so now I have a mark that I want to have visible, and I have a dimension that I don't want to have it change. Let's say my next cut is going to be perpendicular to this, so I can lay down a piece of this tape that does not flex. I can prevent this from twisting. I can prevent it from stretching, and then I can make my cut. So I come along here, and I can see my line. I can cut along it, and the beautiful thing is also I get no frayed edge, and so this edge, I've preserved it. I've kept it from splaying out, and make this a whole lot easier to work with. If there's adhesive or something applied here on the surface, well, while I have the tape, it's not going to stick to this tape. So here I have a thermocouple. If you work with thermocouples, then you really ought to know about Kapton tape. I decided to dive into this because on so many applications, now it used to be only mechanical engineers were the ones working with thermocouples in engineering courses, and they take heat transfer. So nowadays, sensor kits and programmable sensors are so ubiquitous that many other people are taking it that haven't taken a heat transfer course. If you're using a thermocouple, you would just be using a thermistor unless your temperatures are high. So at 200 Celsius, let's say we want to measure this temperature of this steel. Well, let's say you pin it down with a piece of tape, and or you're fastening it because tape won't withstand the temperature. Okay, if you're doing this, you're not measuring the temperature of the steel, you're measuring the temperature of the air, and you will lose enormous amounts of heat because of the heat will be lost at that interface between the air and your steel. So just putting an incredibly thin amount of insulation on top of it is going to improve your accuracy by huge margins. Usually we're using thermal paste, but it depends on how accurate you need to be. Okay, so now you have this pinned down, and at 200 Celsius you're okay with the Kapton tape, and a whole lot better result you'll get if you add some insulation and then you tape it down. So this combination, fiberglass, tape, and the thermocouple, is a recipe for a great deal of experiments. And then in the case of, let's say you're measuring a temperature that's above 200 Celsius, and now you have a temperature probe, and let's say this whole block is hot. So now I want to measure inside of something, and I'm going to insert the probe. The probe can tolerate the heat, but now I'm going to have a transfer of heat from this to, let's say, the enclosure. Let's say your enclosure is made of something that's not heat tolerant. Well, you have a heat transfer situation where this body will heat up, and you have conductivity of heat all the way to the surface of what you're mounting to, and that's problematic. So just something as thin as this in between is going to give you a drastic improvement in reducing the heat that's conducted to your enclosure when you mount that on, and even further with something like fiberglass. So then the last part is electrical conductivity. So what the mechanical engineers often fail to consider is that you will inject noise. If this is an engine or a jet or something that has motion, EMF, electromagnetic noise, then if you allow there to be an electrical conduit from your machine to your sensor, this can cause a huge number of problems. This was actually a problem way back in my junior year in undergrad, and we didn't know we never solved what the issue was, but our temperature was swinging up and down, had tons of noise. So something like this true aluminum duct tape is the go-to solution in many cases, but what you'll do is, okay, we've made sure we're protecting the apparatus from too much heat, but we're not protecting it from electrical conductivity. And so using an aluminum tape instead of a polymer, you are going to allow that conductivity to travel all the way through to other parts of your circuit. So that's a no-no if you can avoid it. The next thing about aluminum foil tape, which is found at Home Depot or home repair stores, is it can reflect light, of course, including infrared light. So I'm seeing these infrared temperature measurements become more and more used, including also the video cameras like FLIR adapters that plug into your phone and give you an infrared video. But you need to be extremely cautious about how you're using that to measure. If you're using anything that's reflective or transparent, now you're giving huge room for error. So like these are duct tape, standard duct tape that's white in color, and the aluminum foil. And if we measure each of these, 27.5 to 28.8, we're getting very different readings because the emissivity value of these surfaces is different. And in the case of a transparent tape, you have possibly that you're getting a blend of emissivity of the steel and the tape itself. So I don't trust something that's reflective at all for infrared measurements. Now 27.4, 27.4, 27.4. I consistently use the plain white or beige masking tape to cover an item that I want to measure the temperature of, especially when I'm comparing two items. In the case of this ruler, it's steel and the emissivity is not, it is very deviating from the average material. So things that are shiny are going to be, or they're going to throw you off for sure, unless you can adjust this to the material, an adjustment on your instrument. Now, if we don't know the emissivity, we can still work through this. So you take one measurement of the surface that you know is accurate with some instrument, and then you can just check the delta in temperature. We're going to save this measurement. We're going to say this is plus X, and then you can measure how much is, if you have heat being supplied somewhere in here and you want to know where it's warmer, now we can take relative measurements from one space to the next. Then relative measurements between two materials, I'll apply the diffuse beige tape to both materials. Now I can generally trust that I'm getting matching values. So this is all, should be ambient temperature. All of these materials should be matching in their temperature truly, but we're getting these different readings. Now, if you have heat being supplied, duct tape is a really bad idea because it is so thick, and that adhesive is an insulator. So if you're not working with the ambient temperature of the item you're measuring, then like if this is heated, then we're going to lose a lot of heat. Even if you were to, let's say, put this on there, now you've created an insulating barrier, and you don't want to do that. What the aluminum tape is good for is conforming to shapes, because it will stretch and then hold its shape and its position. So let's say I need to drill a hole somewhere in this region, but I'm not to touch the embossed area of this knife. Then I can press this down, and when I push on it, now it's going to hug that contour, and I can see very easily what's going on still on the contours underneath. Then I can drill my hole, and tape is really good for helping you get cleaner holes in fragile materials. So that's another thing. Speaking about not sticking, there are these double-sided tapes for very strong jobs, and they are extremely tacky. They have a lot of conforming due to their thickness, and I've only seen clear and black. The clear one is made of acrylic. It is a little bit lower cost, and then you have Gorilla brand and several other brands that carry this somewhat foamy but very tough tape. And so they have a backing on them always, because they would stick too much to themselves. And if you need to get that precise shape again, I'd recommend finding something clean and non-sticky to stick it to. Basically wax paper type of things. If your cutting boards are made of nylon, this one is PVC, so PVC, nylon, HDPE. You can lay these down without losing any of their tackiness, and then you can cut it to the shape that you need, and then you can proceed from there. So these are very expensive. I don't use them very often because it's basically doing the job of trying to put an adhesive glue on something. I treat this as if it's permanent, and I really only use it with a lightweight item that you may want to post up temporarily. Sorry, let's say I needed a device stuck onto here permanently. If it's a light item on a flat, smooth surface, then smooth is okay. But if I want it to be bearing loads, then we need to be working with a porous surface like wood, and that will get you a really incredible bond here. And this one, you, just like other applications, you're going to have to press it firmly to get it to stick. And so the 3M packages usually they indicate that you need to press for a certain number of seconds. So you can do this. Let's see if we can get a good angle on here. If I push on this, so I've just gently stuck it, and you can see only about half of the surface area has really bonded. And if I press and sweep my finger across, then I'm getting it bonded across all this acrylic. So you can work from the inside out, or some pattern you really want to keep track that you've covered the whole surface by applying pressure. And then you're going to remove the backing on it. And removal, that's a hit or miss. After a few days, I can't tell you, it really depends on the surface, but if it's a strong and non-porous surface, you probably can remove it. Kind of like those 3M fasteners for hanging pictures. The stretching of the plastic will cause it to set free. And if you can't stretch it, if you can't access that tab to pull on it, then you are SOL. Still, this, I wouldn't count on it to be in high temperatures, such as on a hot summer day inside of a car. You might not last but a couple of weeks. Let's say you're cutting a composite material and you don't want to get this rough edge. When we're using the circular saw, when the blade comes up, the tooth grabs this area and it lifts on the top layer of your material. And so to prevent that, it enhances the cut by a huge amount by first laying down some masking tape. And then also, if you're cutting on the opposite side, if you're cutting a dark material or a rough material that's hard to mark on, now we can get a fine line here that you could not get on here. If you're aiming to get a precise distance from the bottom edge, for example, now we can make a thin mark that you can still see visibly, whereas it's very hard to see this thin mark, especially if you have sawdust accumulating. So this is great for visibility. You may have just noticed when I lifted the tape on this edge that it came up with some of the material, the white material, and took it away. So when you're doing the removal on a composite material, peel it away from your edge and you're not going to lose any of your surface. Non-flexible tapes are also really good measuring devices. I'll show you here. If I wanted to have a straight line that goes around the circumference of this tube, and I want to make sure that it's perpendicular, then I can just take two marks, make them carefully. Then when I lay the tape, I can just start at one line and go to the next one. And by making sure that my tape is not wrinkled, see, I've gone too high, so I'll make one more adjustment. Let's see how that gets us. And we're gonna lay that flat. Now draw that all the way around the tube, and I've only lost squareness by 1 millimeter. That's pretty good. And so by taking care and making two very nice measurements, then you can have a perfectly straight ring around here that's ready for cutting or fitment in something sensitive. In the same way, it can be pretty hard to, on a round stock or a different shape, have a consistent line, let's say at 45 degrees. So we're gonna make sure that this is sitting flat. We're gonna just make one mark, if you're as precise as can be, and only mark the region where you're in close contact with the plastic. Then you can reapply the tape. Okay, I've laid it down right on the line. You can maybe see it there. And now I have a guarantee I've maintained a 45-degree straight line. And it's because of the width of this tape, any deviation from straightness would result in a wrinkle. And so the tape is informing me that I've maintained my line. And maybe with perspective, you could see the straight line. Yeah, hard to see, but very helpful for measuring. People underestimate how difficult it can be with just hand tools to eyeball it and drill a hole through both sides of a tube, metal, plastic, or otherwise. And this one was just eyeballed. I actually did a great job, but if I want this hole to be perfectly aligned and midway from here to here, for the center of this pin to be at the center of the circle, then simply using a tape, measure the circumference, make a mark, and take half of the circumference to make your other mark, then you can get that straightness. Next we have this tape. I believe it's advertised as silicone tape. Now it has a backing that's not flexible. Once you remove the backing, then it's going to stretch a great deal. And the characteristic of this one is it has no adhesive at all. So we're looking at unstretched. It's about 1 millimeter in thickness. And when you stretch it, it will stretch immensely. It can be hard to get this backing off of there. Okay, and then it only bonds to itself. So there's some sort of vulcanization action that's happening, and you can see we can go a really long way stretching it, and it will come back to its original shape. There are a few instances when I really don't want an adhesive, but I do want the tape to be self-adhesive, and what you get here is I strongly recommend that you stretch it significantly before laying it down on itself, and in just minutes it begins to bond permanently from one layer to the next. This is why they have the polymer film in between. So I've used this in, for example, adding a grip to a tool, or to protect a sensitive material from being scratched by making a wrap around it. And there was one other great application that only this could be the answer to the problem, but I can't remember it right now. Anyway, you can kind of use it like rope in some ways. You can create loops, and then that loop has strength to it, even without giving it time to vulcanize. It's got some strength. Pretty expensive, and remember, you don't get very much on a spool because it is so thick. I've also seen this in blue, and maybe only black and blue. Next up, we have mesh tapes, often consisting of fiberglass or a strong polymer that does resist stretching a great deal, but you can conform it to a surface before you've applied it. So if we want to get this laying down, now we can get that to happen around the edge of this, and the adhesive is not very strong. These are intended, initially you will most commonly find this as a backing for mud / drywall on a house. So when you're needing a substrate, a backing on which to coat with putty or putty type of material, now we can bridge gaps. So if I wanted to seal this with a permanent layer of drywall or maybe epoxy, or even then I could lay fiberglass on top of this. Now I have something that's strong, and the strength is really, let's see, you can tear it. You can tear it sometimes and not other times. The fibers in this long direction are much stronger than the tearing across. So again, you need scissors, and then we have, I believe, this black one. It has no adhesive on the back of it, and it is a little bit stronger. I think you cannot tear this one by hand. Yeah, absolutely cannot tear this one by hand across. And it came in a really wide strip. Can't remember the intended application, but gives you more strength than this one, yet it has no adhesive to it. So if you're going to plant this on something, you'll have to clamp it or use another tape, which you can do as it'll sit in the gaps. Here's an example of a wall where you can see the fiber tape behind it. So the tape is laid across this corner, and then putty is used to fill it in. We would basically call those plasters, plaster and a putty knife. You just smear it in, and you can use multiple coats until it's completely concealed. Tapes are good for adding strength to a joint where we have waterproofness and bonding strength from a silicone or some other adhesive, and then we have the tensile strength that keeps the bottom from falling out when I load it up with equipment that's going in the up and down direction. You can wrap this around the two materials, then you can apply your putty to make it pretty. I often see prototypes using JB Weld for its strength, and at times it has a great compressive strength, but it does not resist vibration and impact. It's brittle. Once it's cured, it's brittle. So if I wanted to put these two together with JB Weld, perhaps applying some at the joint is helpful, but you can probably double your strength adding a couple of layers of this fiber tape and select one that has actual fiberglass, and then embed the JB Weld on that joint. You will probably double your strength. So if the material cracks in the middle, let's say this keeps it from a catastrophic failure or your parts getting lost on a moving assembly. And then in regards to silicone applications, silicone has probably a better bonding strength than JB Weld for most materials. That is, the adhesion between the surface and the adhesive, but it can stretch. And so if you need to avoid deformation and twisting, then you can still use the silicone, but also reinforce it like so, and apply the silicone there too. Now you have tensile strength that resists a huge deal. It resists the deformation. Next, we have fiber reinforced plastic tape that is actually using true fiberglass, and it is extremely strong. Don't even try to pull it apart with your hands, and you will see that the tensile strength, probably without deforming, this can probably carry 100 pounds at least in tension. So this is only going to work, the strength is only relevant if you're pulling it apart and you've bonded it on the same plane that you're pulling. So this doesn't do you any good adding strength if, let's say, I want to tape this down and then lift it, then it's only going to be the same strength as any old packing tape. So let's see if we can pull these apart by applying a pressure like this. So I've clamped the bottom block into a vise, and I set the top one only with one layer on the back side, one layer on the front side. I'll drive this in for leverage and push. So the stickiness failed before anything else. If you, we didn't even damage the fibers. So if you are to wrap this around your assembly and give it a couple layers of adhesion, then it's going to be incredibly strong. Oh, what the heck. While I'm here, I went ahead and wrapped it around the full circumference and overlapped it about that much. Now, let's try and push it apart. I've never tried a test like this. Oh, well, this time it sheared. Oh, okay. It sheared at the corner as if it were cut by this sharp edge. There you go. So this fiber reinforced tape is very affordable, and it's tempting to just replace any packing tape with it because it's vastly stronger than a cardboard box. However, this is much more advanced than most people talk about, and the properties for handling temperature is optimized. If you get a name brand like Scotch for packing tape, this clear tape handles low and high temperatures much better than this. So a non-air conditioned packing truck or packing space, you're going to find that this in a hot car or someplace like that, it will get gummy, it will leave a huge amount of residue and even little strings of fiber on your material, whereas this one is much less likely and easier to pull off. In high temperatures, you'll find a residue on something like if this is applied to painted metal, you'll peel it off and it will give it a year. It's going to leave behind all sorts of sticky tack. And but in low temperatures, if you want to apply this, it's still going to be flexible enough to bond with something, and the adhesive will still have stickiness in low temperatures, whereas not so many guarantees for this one. Low temperature, expect this to perform poorly and may not work. In high temperatures for short periods, like a week, it's almost as if this was very optimized for shipping, because you don't have it becoming like viscous and sliding off of the materials. You don't have it leaving behind residue in a few days of high temperature. So this is actually a splendid invention that I think probably doesn't have as much credit as it deserves. All right, the ever famous duct tape. It is very workable to tear by hand, but I hate it. In the last 12 months, I've used almost every tape that I've demonstrated so far, but I've only used duct tape for one thing these days, and that is to wrap up utility blades before I throw them in the trash so that no one gets cut. It is great for protecting sharp surfaces because of its bulkiness, and it's great for throwing in the trash because it's only a matter of days before it leaves behind an awful, terrible mess. And if you even momentarily make contact with itself, now you're going to have this, the adhesive will be just a mess. It will not be evenly distributed anymore, and I'm just not a fan. For almost every given application, you have a specific tape that does a lot better. For almost any application where I'm even remotely tempted to use duct tape, I prefer gaffers tape. This has a much more consistent adhesive. Okay, it's just as tacky. It's very tacky when you stick it to itself, okay? But bonding to various materials like rough surfaces or porous surfaces that have dirt, it can handle that. When you tear it, it has a much cleaner tear, usually. This is a decent brand, and it's gonna cost between $10 and $20 for a roll. But it lasts so much longer than you expect. You might get 50% more length on the same size spool for this tape compared with duct tape. The layer is much thinner, and the traditional use is for people setting up studios, etc., and they want to mark lines for filming or secure wires down on the floor. And the conforming is very nice. I have left it on surfaces for almost a year and peeled it up without any problem. That's amazing. Not leaving residue on my cables, not leaving residue on my plastic or wood surfaces. And so that is absolutely incredible. And then you have this matte surface. It doesn't reflect light. It doesn't get snagged on tacky items. Like, so if I need something to slide over it without grabbing and peeling, this is much better. You have almost that same feeling as on the medical tape. However, it is embedded with some sort of rubbery polymer. The feeling is great. That embedded polymer gives it waterproof as well. So if the very end of your terminal needs to be covered up and waterproof, you can be sure that you're not going to get water intrusion if it gets splashed. So that's gaffers tape or gaffing tape, and it comes in several colors as well. Neutral colors like beige are common, so it's not easy to notice. Okay, we're almost finished. This one is called PTFE tape, or pipe thread tape, or Teflon. Teflon and PTFE are the name brand and chemical name for this material. It's one homogeneous material. It does have a grain direction, so if you pull it, you can split it that way a lot more easily. And if you stretch it, it's gonna get narrower. Well, usually narrower while you are using it. Okay, so the most common use for this tape is to coat threads. Okay, the most common use for this tape is to coat threads, specifically pipe threads. These threads are for mating for an airtight and watertight seal, and the PTFE combined with this thread type can allow you to support very high pressures and keep it completely sealed. So you have a conical shape. It's not a straight thread as most screws. It's actually tapered. So that's a tapered thread, male inside the female. And in order to create a seal, unlike your hose, where you would have a gasket at the bottom face of this thread, these threads will not reach all the way. There's an interference, and the interference reaches at some point as this diameter expands and mates in here. And then to sit in between each thread, you have this PTFE tape, which occupies those very small gaps, and as you compress it, it's going to fill up all the gaps. Then you have airtight seals. The tape itself, these are pretty affordable, maybe $3 or $4 at the hardware store, and the quality varies quite a bit. You can trust that the material is the same with a cheaper variety, but usually the thickness will start to get very, very thin, and it's even hard to work with if you have too thin of a material. So sometimes you'll buy some sort of hose kit or under sink repair kit. It'll come with this stuff for free, it's worth holding on to, but get a thicker one, and you can read when you purchase them, you can read the actual, the thickness will be designated if you buy a name brand. So in this case, we have the width, we have the length, thickness is not indicated on here. Then you have a yellow version of the same thing. Chemically, I'm not sure if there's any difference. You could ask a plumber, technician person who's trained, and this is designated, it's quite a lot thicker, and this is designated for gas fittings for combustible gases, such as the natural gas pipes in your home. So that's much easier to work with, and if you're doing your own custom application, this will allow you to cut a length and manage the piece that you have in hand when you're doing something particular. This material in general is very low friction coefficient. You can actually wedge it in between two materials, and you're going to get something that's very difficult to slide will be then easy to slide, perhaps like a rod inside of a cylinder. Okay, of course there's no guarantee it will hold in place because it has no adhesive on its own. And the Teflon is also very resilient against most chemicals, so solvents such as gasoline or kerosene, acetone. Probably you should look it up, but this is a good place to look if you need to hold up against something like that. Side of pipe threads, you may have one other custom application that I could think of that you might want to use this for, and that is to contain fluids with ordinary threads. No guarantees here, but if you need a creative solution in a pinch. All right, so this is a rivet. It's stainless steel, and if you had a reservoir like a cup of fluid and you need a tough material like stainless to hold up and plug the bottom of it but have it removable, then you could put a rivet here. You could caulk it with silicone or some other resistant material, gasket, etc. on the inside, or you could even solder this. You can solder steel on steel. And then you could wrap around the diameter, the face of the bottom of this screw. And when you thread it in, if you wrap it tightly and get a circle on it, if you have no rubber O-ring, then that pinching action will allow you to compress the PTFE and probably get a watertight seal for low pressure. So just the pressure of having a fluid in a cup, etc. Most of the fittings related to pneumatics, you will always find a tapered thread, and tapered threads always need some sort of thread tape on them to perform their seal as designed. However, not everything that is pneumatic has such a tapered thread. You can measure these with calipers and you'll find that some of them are not tapered at all. Then you have fittings like this one. This is a compression fitting where the O-ring is performing the sealing. These threads are pulling the component up against, to mate up against a wall, and then the compression of that O-ring is going to do the sealing and not the thread tape. These thin tapes here are vinyl tapes. Probably you can shop for these under the keyword pinstriping tape or vinyl colored tape, and they usually come in a pack. These are really for communication. By that I mean we can have labels that we don't need to worry about the number or characters, and simply match up the colored items in the workshop, and this is very valuable, fast, and no need to wait for drying like you do if you have a liquid color, a paint. Okay, so then we can match up, designate things in the lab, and this is probably very close to PVC, so it's a vinyl generically, but you can expect that the material is very close to the same material you'll find in the in electrical tapes. So that means it's flexible, stretchable, and you can route it around corners easily while keeping it flush, but you cannot expect it to be free from deformation. You will not have the rigidity, and it will not hold up in high temperatures such as a car or in an attic. Then this will slide and become gummy and very likely peel up. Another useful tape is without any adhesive at all, found in your craft store or sewing store, and it's made of a glue itself that is a high temperature glue. So if you wanted to bond two flexible materials such as cloth, then you can lay this in between and lay it down and iron this, then it's going to melt. And the properties of this this glue, this tape, are very similar to hot glue. You can expect the temperature range to be similar, where 100 Celsius will surely melt it, and a very short amount of time it takes. It will melt quickly and re-solidify quickly. And you might want to have 2 layers if you're doing something thick like canvas. There are loads of different styles of these that I have not tried out, but just having one on hand to verify, okay, I can get this to work with my material, and it optimize further if I need to by shopping around from there. But there are some instances where nothing else on the shelf will do the job except for this. Okay, the last one is these foam types of tapes. They make a good thermal insulator. They're usually not a very strong material itself. They're double-sided stickiness. And what I've found is they tend to have a better adhesion strength than the strength of the material. That is, so if you bond 2 items nicely, some steel or smooth surface on each side, and then you tear it apart, you're going to get a failure in the foam itself. You can get something looking like that at the end, and it will take some scraping to remove it. The application engineering wise that you would want to use this for is, just like they did in this appliance, we're eliminating vibration, or we're doing leveling. So if you have an item that can wobble, and the flatness, you don't have a guarantee on flatness, you need it to sit flat on something. If the item has some weight, you can apply this foam tape to behave like feet. Of course, you can also purchase feet that are dedicated with a prescribed size. And then that ability to compress will give you just enough flexibility to have something sit flat. It'll compress on the high points, and it will compress less on the low points to give you a flat mating. So keep in mind, when you're using this, you are basically behaving, this foam is behaving like a spring. So if you double the length of the spring / thickness of this material, you are cutting in half the spring constant. That is, the same amount of force will deflect 2 times further if you have 2 layers. And in the opposite direction, if you have twice the surface area, the square inches, square centimeters, then the same force being applied from the top side here will deflect it half as much. You'll have half as much movement of this base if you have twice as much tape surface area being compressed. So that's useful. And then lastly, it's practical to take this, let's say you're working with, and you got to remove this backing. This one is 3M. By the way, 3M, this pattern is one of their trademarks. You will find that the quality ranges very, very widely. This is light. If you're wondering while it's in a package, is this the foam type? This it's very lightweight compared with the acrylic types of squishy. That's not foam, not porous. The one shown earlier. You'll feel that it's lightweight. You'll see that it's usually white and comes in all different widths. So you have a cheap no-name brand. This could be $1 for all this, and sometimes these will be $5 just for a strip this long. 3M does, however, offer data sheets and a lot more information you can look up so that you can have very precise qualities if you're looking for them. Back to the other remark, that is, it's practical to make, if you're wanting to have a foot, but we don't want to bond this fan to a surface, you're going to put this here, and then you can lay on top of it something like a fabric tape, so then it doesn't bond to anything on the bottom side, and the foam itself stays on your device. A very good use case for one of these compressible two-sided tapes is eliminating vibrations. So in cheap appliances, you'll have a thin wall somewhere. You have rotation or whatever, and you'll get a rattle. You can strike this, and like that wall, it's going to echo. If you have a machine vibrating inside, it will just be loud constantly. So this wall has very little mass. And then in a mid-range, high-range appliance will just be made out of a thicker gauge material so that it has mass. That changes the vibration characteristics. So what we would do, if this was a thin metal and I wanted to dampen it so the noise goes down, then what I can do is grab a full covering of this tape, put it on a nice weighted piece of steel, etc., and then bond it inside of that housing. So then when you strike it, the oscillation, the frequency that you're going to get the vibration is much lower, and it will deaden that oscillation much quicker, and it will just dampen the noise overall. So consider every hollow contraption that you have to be a drum, and you can find in the drummers shopping, if you have musician friends, that they make sticky heavy weights that can be placed inside of drums specifically for that and change the acoustic characteristics of an enclosure. To demonstrate with this thin piece of metal, you have a noisy and ringing thin metal, and if you were to scrape it or have a machine inside, you get all that noise. And then we can use tape. This happens to have magnets. The effect is the same now. Much less noise and reverberation, and the scraping is deadened as well. Oh wait, there's one more. This is a plastic polymer tape with a adhesion that's a little bit better than an electrical tape. I use this similar to masking tape applications, but in the cases where I want to have waterproofing, or I want it to sit longer before I need to remove it. So the conforming feature is good. It's a little bit less stretchy than masking tape, it'll tear like that. Think of a really hefty trash bag, and that's what the feel is. I'll look up the name of designation for this type of tape and share it in the description. But as you can see, it'll conform to things, it'll stick for long periods of time, and usually peel up with less residue compared with, let's say if I leave painter's tape on too long, it's going to shear all around and come off in many pieces. Like the blue painter's tape, this one will still come off in one piece no matter how long it's been on something, and leaves a little bit less residue, just the quality is nice. Lastly, great for adding labels to things that you may want to change later. Beautiful white that you can write on with a Sharpie, no bleed.